In this lecture, I like to explain the fractional distillation to calculate the number of stages. Generally used method is McCabe-Thiele method because it has very easy. We require only XY data. For this purpose, we require the three important lines. One is the rectification operating line and Q line and stripping operating line. This general diagram, this is called as rectification section, this is called as stripping section, and this is called as feed position. We have assumed that molar heats of evaporation of the feed components are equal. For every mole of liquid vaporized, 1 mole of vapor is condensed. This is the rectification section. To develop the operating line equation, we do the metal balance, overall metal balance, and the component balance. So this overall metal balance from the above diagram will get Vn plus 1 is equal to Ln plus D, that is equal to, for more volatile component, it is equal to Vn plus 1 into Yn plus 1 is equal to Ln into Xn plus dxd. By simplification and using the appropriate assumptions, the equation becomes Yn plus 1 is equal to L by V into Xn plus D by V into Xd. That is, the operating line will have the slope of L by V and the intercept of D by V into Xd. You can write by defining this as by using the term reflux ratio. In introducing the reflux ratio term, R is equal to L by D. Then Yn plus 1 is equal to L by L plus D into plus D by L plus D into Xd. So after simplification, we'll get Yn plus 1 is equal to R by R plus 1 X into Xn plus 1 by R plus 1 into Xd. So this line will start from the position of Xn, Xd, Xd. So this is the position of Xd, Xd. You can construct the number of stages by drawing the rectification operating line and the equilibrium line. The number of stages can be constructed by taking from this position, draw the horizontal line up to the equilibrium line, draw the vertical line up to the operating line, repeat the process until it reaches to the feed position, it crosses the feed location. So the feed operating line will have the feed enters at the particular plate, that is called as feed position, and if the moles is F, the L moles is from the rectification section, and some moles is added to this, and the moles becomes in stripping section L dash. Similarly, V dash and V. We'll define the Q is the heat required to convert 1 mole of feed to a saturated vapor divided by molar heat of vaporization of saturated liquid. Depend upon the feed condition, you may have the Q of different values, maybe greater than 1, less than 1, or equal to 1, equal to 0, or in between 0 to 1. These are the various situations for the feed. The feed may be cold, then all the feed comes to the stripping section, and some amount of the vapor is condensed. If it is a saturated liquid, all the feed will goes to the stripping section. There is no vapor condensation. If it is a partial vapor mixture, then some amount of liquid comes to the stripping section, some amount of the feed goes to the vapor section, rectification section. Similarly, if it is a saturated vapor, all the feed goes to the in the vapor phase. If it is saturated vapor containing supersaturated vapor, then all the feed will enters into the stripping section and some amount of the liquid is also vaporized. So we'll represent generally the Q is the fraction of feed enters into the stripping section for 1 mole of the feed. Say for example, feed is F, then the liquid enters is equal to Q into F. Similarly, vapor is equal to 1 minus Q into F. So writing the overall metal balance, and if you simplify, we'll get the Y is equal to minus Q by 1 minus Q into X plus 1 minus Q into XF. So this is the slope of the operating line. This is the intercept of the operating line. So you can conclude that this position is from the position of X and XF. If you draw the line, you will get the feed operating line, feed Q line. So this Q lines will appear like this. For the cold fluid, it is like this. For the saturated, it is like this. For the vapor, partially vapor, it is like this, like that. So this is the stripping operator section. You can see that the B is the component coming out, distillate residue coming out. So if you draw the metal balance again, we get the operating line is equal to Y is equal to L dash by V dash to X minus of B by V dash into XB. So from this, the slope of the operating line is equal to L dash by L dash minus B. The intercept is equal to B by L dash minus B. So this is the equilibrium line. This is the equilibrium line. This is the stripping section line. Sorry, this is the rectification section line. This is the stripping section line. This is the feed line. Now construct the diagram. Construct the staircases as explained previously. Then you can count the number of stages. Here for this separation, the number of stages is equal to 6. So for this, how to do that, how to calculate the number of stages. First, what we have to do is draw the 45 degrees line, then equilibrium line, then identify the position of XD, identify the position of XB. So you can get more information regarding this method in the following links, YouTubes. Thank you.